Now I would like to call Shri Kaushik Srinivasan, the Executive Vice President of E-Mudhra. And I would like to call Shri Ashish Banati, the Deputy CA, to present the memento. Please, sir. Shri Kaushik Nivasan, a technology entrepreneur and one of the co-founder of E-Mudhra, responsible for building technology platforms that are integral to Indian digital public infrastructure to derive paperless and presenceless way of doing business. Please, sir.
Good afternoon, ladies and gentlemen. I want to first thank the Office of CCA and the organizers, CDAC, for giving us an opportunity to speak on this very interesting topic, particularly on zero trust and how mobile PKI can bridge the gap in terms of enabling the secure transition or enabling the movement to zero trust. And this is a topic that's very close to our heart, so we've been doing a lot of work in ensuring that mobile PKI really is the future of what we call a secure integrated digital society. So just a little bit of what is zero trust. It is really the new cybersecurity paradigm that's emerging based on the principle of never trust, always verify, which essentially means any access to resources at the user level, at the device level, at the networking level, at the data access level has to be protected, has to be secured, has to be identified before granting that access. And that's really the paradigm that's emerging based on the principle of never trust, always verify, which essentially means you have to verify users, you have to verify the devices with which people access these critical infrastructure. And this is where we feel mobile PKI can play a significant role in ensuring that. We had a very interesting talk prior to mine by Mr. Robert Raja, who also identified that enterprises are today subject to data breaches like never before. And this is putting a lot of strain on reputation, because once a data breach happens, there are obligations to notify immediately. There are public reputation sort of repercussions. If it's a publicly listed entity, there are regulator obligations that you have to sort of meet. So the idea of zero trust is gaining more and more prominence, gaining more and more momentum, and we feel mobile PKI can play a pretty important role in plugging in that sort of gap. So again, a bit of context. So the foundation layer for all of PKI is really cryptographic keys. We've had RSA, ECC and variants of it for the last 2 decades. Now we are moving into the world of PQC based sort of keys. Once a key is married with an identity, you get a digital signature certificate. So it could be a user, it could be a website, it could be a device. And the certificate can really be used for 3 things: user authentication and access, 2 is data encryption, and 3 is obviously powering digital transformation in a completely presenceless and paperless manner. All 3 are very big in their own right, because today authentication needs to be more secure. Many of us continue to use passwords or OTPs to authenticate, and even as recently as a couple of months back, even the central bank, which is RBI, has said, let's move away from OTPs because they are not that secure. The data privacy laws globally, data privacy acts, are forcing people to encrypt any kind of personally identifiable information. And again, the same foundational technology is used. And 3, for signature workflows, for transformation in lending, for transformation in banking, for transformation in insurance, again, the same foundational technology of digital signature certificates are used. So the usage of digital signature certificates is gaining exponential momentum. It's only time that we provide more convenience to this usage. And how do you really do the convenience? Today, many of the usage is driven through these crypto token devices, which inherently limits the number of use cases that we can sort of drive in the context of digital transformation. But if this comes to the device, which is each one's mobile phone, where digital signature certificates can be enabled, we can significantly increase the usage across banking, across insurance, across various other use cases, where digital signature certificates need to be repeatedly used, either to identify, either to sign, either to authenticate, or even to encrypt data. So on the one context, we have zero trust, which is a new paradigm that's emerging. On the other side, how do we promote the use cases in the country and set a role model for the rest of the world to follow? We feel mobile PKI can be a very critical component in bridging these 2 worlds and 2 gaps, where it can really be the future of secure digital transactions. So what are some of the advantages of mobile PKI? Obviously, very robust identity verification because the certificate is sitting in the phone in your custody. Today, the tokens, there's common practice that many of the people that sort of use digital signature certificates in a crypto token sometimes hand it over to their chartered accountants, whereas nobody will hand over the mobile device to somebody else. So robust identity verification plus the protection of key custody, highly sort of secure. You can automate the whole trust life cycle with the PKI in your mobile, which pretty means you have the control of it. You can enable sort of or ensure when it gets renewed, when it gets reprovisioned. There is huge interoperability possibility because everything is based on common standards. Non-repudiation being very big and very critical to many of the sensitive transactions that we do, for instance, in banking. And how do we future-proof it? Because mobile devices are again becoming more and more powerful. So as the world transitions to, for instance, something like post-quantum cryptography, we can enable it through the mobile itself. So there are a lot of benefits, and the most fundamental important thing is the key custody. A mobile device always remains with the person. Very rarely do we hand it over to anybody else, right? And it's protected with authentication built into the mobile, like face or biometric or some other form of authentication. And putting a digital signature certificate in the mobile in a secure manner can really explode the number of use cases that PKI can offer from an end user perspective and sort of take PKI into everyone's sort of hands for even high value fund transfers, cross-border trade, insurance claims, and so many other common man use cases. And possibly one day we will see an evolution of PKI where it becomes a consumer to consumer commodity, where even rental agreements and contracts that are exchanged between two citizens are enabled through PKI, which today are on paper, right? Because if you see the history of PKI, at least in India, it was first mostly business to government. Now only we are seeing the adoption from a business to business or a business to consumer, but we would like to see it as a consumer to consumer adoption of technology, and this can be powered or enabled through mobile PKI. So again, the adoption of mobile PKI and why now, right, is an important question, because so far, I think up until 2-3 years back, the phones did not have the relevant security to hold a digital signature certificate. All of our security standards are mirrored based on either global standards like FIPS or certain other standards like EAL, right? And we typically sort of borrow a minimum security level of FIPS 142, level 2 for storing a digital signature certificate. But the innovation has sort of happened on mobile devices. Players like Apple, players like Samsung, and even Google, their phones and the secure storage layer are now compliant or certified for FIPS 142 level 2 or the appropriate protection profile in the context of EAL. So they can hold keys and certificates which are fairly secure. And that's really the reason why mobile PKI, we feel, will take off, you know, in the coming years, because it's also really the foundation for future technologies such as digital identity, digital passports, digital wallets where your credentials are stored and you can sort of use that to transact anywhere on the planet for any kind of e-commerce. So this is how it works. It's pretty simple in the context of usage. As a certifying authority, anyway, we issue digital signature certificates to crypto tokens that are certified for FIPS 142 level 2. It's the same model. There is a server which is operated by the certifying authority, and then the device. The device has an app. The app basically allows you to download certificates or create key pairs first in the secure layer of the phone, and then send the CSR and get the certificate back, which basically gets stored. If you are running an enterprise and there is a directory server, you can connect to it to pull certain types of KYC information or do a KYC against a federal sort of identity scheme, which in the context of India is Aadhaar. But the idea is the phone then behaves as the storage layer where the keys are created in a non-exportable manner, in a highly secure manner. And then any application that wants to basically authenticate using the digital signature certificate on the phone or get a user to sign a document basically does a simple API call through a server, which then triggers a push notification on the mobile phone based on which the user sort of authenticates or signs. So from a user experience standpoint, it completely simplifies many things. One, there is very little sort of logistical sort of issue of how do you deliver the tokens. Second, the need to use drivers, etc., on the tokens to download the certificate, that also is, you know, mitigated. So I guess the mobile world is fairly simple. It's just a simple app, simple interface that allows users to download certificates and use the certificates. The rest of the complexity in terms of security is obviously handled at the app, the operating system, and the hardware layer, which are all certified to global standards. And this can then be used to kind of authenticate users against public sort of repositories or public portals, or even your internal enterprise sort of devices like firewalls. When you want to have an admin authenticate, you can sort of use this technology. It can be even used in closed user group circumstances. So possibility significantly improves with the ability for mobiles to basically now store certificates and use that for secure authentication or secure signing. So the core of the mobile PKI interface is really the ability now to issue certificates in something called a secure enclave or a strong box. These are dedicated hardware that are completely isolated with separate secure processing that are only restricted to crypto operations. So we can be rest assured that these hardware are basically certified chips that only allow key storage, key operations in a completely secure manner with the relevant tamper proofing and tamper detection. And these are certified to FIPS 142 level 2 as in the case of iPhone. And in the case of Android, many of the hardware manufacturers are certified to protection profiles that are more on the EAL side. But the idea is it's completely isolated like a token where the crypto operations happen in a separate layer with a separate processor, mitigating any kind of attacks like side channels, etc. Right? So that's really the core foundation with which we are building the mobile PKI architecture, that it's isolation of keys, isolation of storage, isolation of operations, and the usage in a completely tamper-proof manner. So what has Apple done about it? Apple, obviously being a US company, they've taken the FIPS 142 level 2 certification. This is available, I think, from iPhone models 11 onwards. So many of us today that are using 13, 14, 15, and likely the 16 are basically already having the relevant hardware on which the keys and certificates can be issued. And then this is a fairly secure way of sort of doing it, where now from the iPhone itself, you can authenticate or sign documents through a simple push notification, and the rest of the complexity is abstracted by the certifying authority and the hardware and the OS layer. They call it the secure enclave. The secure enclave is a separate sort of zone in the trusted execution environment, which is isolated only for cryptographic operations. Apple already uses this for a number of their secure transactions like Apple Pay, Apple sort of wallet in which credentials are stored, and many other sort of sensitive data, but this is also now exposed via the OS layer for third-party application developers to also develop and issue keys and issue certificates. The good part is any application that's issuing certificates, the namespace is tied to that application, so other applications cannot access the key. The keys are obviously non-exportable, cannot also access the crypto operations using any kind of key alias or key identifier. So it's highly secure, already being widely used, and we are trying to see how to build on top of this to roll out mobile PKI-based digital signing and authentication through on the iPhone. A similar model is available in the context of Android, but Android being more the operating system layer is reliant on hardware OEMs to supply the relevant hardware. In this context, device manufacturers like Samsung and Google Pixel already have the secure enclave equivalent called Strongbox. The Strongbox is very similar, it's isolated, it's secure, it's tamper-proof. And through the Android OS, there is a concept called key attestation, which tells you whether the key is actually getting created in the Strongbox layer. So again, application developers can really leverage the key attestation model to only ensure that the keys are getting created in the Strongbox layer, which is completely isolated, has a separate CPU, separate storage, separate random number generator, and then use the keys and certificates to do secure sort of transactions, either authentication or signing. So why I'm really saying all this is I think there's a huge wave of digital transformation going in the financial sector in India, particularly in banking, and the regulators are more and more concerned about the usage of passwords and OTPs which are vulnerable to attacks. So I think PK offers an ideal alternative to some of the existing sort of forms of authentication and brings in a completely new dimension where it's the user plus the device that is getting authenticated as part of a transaction and offers a significantly higher level of security, because you not only have channel encryption, you also have payload encryption, and you have identity of the user device linked to the transaction. So we can be rest assured that even high value fund transfers today can be done from the phone, because I think from a global level, India has huge aspirations of enabling cross-border trade, and in cross-border trade, an important component is payments. So when you want to start moving money that's high value, some of these technologies will be required, and how do you really simplify the user experience? You can directly do it from the mobile. So even trade finance, payments, remittances can all happen via secure ways, basically through mobile PKI. So it's pretty simple. This is the architecture You have obviously the certifying authority that's issuing the certificates, but within the phone, there's a TE and a secure enclave, which is a subcomponent of the TE where the key pairs are created, isolated for storage, isolated for crypto operations, and keys are non-exportable, so they never come out, right? So again, to summarize, what are the advantages? Significantly enhanced security, very seamless integration because it's a simple API call, and we can also do various sort of models where it becomes like a PKCS11 interface but invokes the mobile and sends a push notification. Significantly improved user convenience, and basically enable organizations to move to the zero trust architecture because now you're able to identify any kind of transactions that are happening. From a cost efficiency standpoint, even you can move to models where it's per transaction based against per certificate based, highly scalable, compliance because all of these are based on global standards, either US, Europe, and obviously in India also I think there's a lot of work on standards that are going on with BIS, and support use cases for signing and encryption so we can over time phase out legacy ways of authentication and particularly power the move to passwordless. And this is really what we wanted to sort of summarize, but we do have a small video, so I'm going to request Sai to quickly come over and officially at least launch whatever we have done in terms of a pilot project as far as mobile PKI is concerned, and show you how simple it can be from a user standpoint in powering any kind of use cases with respect to digital signature and encryption. So over to you, Sai.
Thank you, Kaushik. Yeah, I hope it is visible. So this is the application that Kaushik was alluding to. This is the mobile PKI application. It's an app which is loaded onto the mobile phone. Now I will showcase how the certificate gets downloaded on the mobile phone, okay, using this particular app, and how this mobile PKI actually gets integrated with an external application. Like we will show you one banking demo banking application, and on that how a user digitally signs a PDF document for the keys that are actually stored on the mobile device. So we will begin with the certificate download which is happening. So you can see the certificate download happens through the mobile app. So the user, when the CA says that, okay, your certificate is available for the download, the user uses the mobile app, wherein the user will be asked to enter the application ID and the challenge code. Once the details are entered, then you can view the data that is going to come up as a X509v3 certificate. Now here what happens, like any other token, here also the key pair gets generated on the mobile device in the secure enclave. A PKCS10 request gets generated. It is sent to the CA via API. The CA will issue a certificate against that PKCS10 request. The certificate gets back to the mobile app. The mobile app will bind the certificate back to the key material, and that's how you can see that the certificate is successfully downloaded onto the mobile device. Now we will show you how this certificate, which is successfully downloaded onto the mobile device, actually can be used for signing a document on the website. Say for example, you can see a demo banking website where the user has uploaded the PDF document. Now here what's happening is, at the time of signing the document, the user is asked to pair the mobile device with the system. So once the pairing is done, then the user will get a push notification stating that, hey, there is a document that you have to sign. So here what will happen is only the hash of the document that comes to the mobile app, where the using the hash, we pick up the private key, a digital signature gets generated, and the signature is sent back to the calling application. The calling application then embeds that signature back onto the PDF document, and the signature is done. Yeah. So that's the demo of the application.
So you can see how simple the user experience is, and the idea is obviously how do we expand the scope of the digital signature market in the country and globally. and we feel that mobile PKI is a significant step in that direction. We will, of course, be launching certain pilots to demonstrate in critical use cases, and then hopefully over time roll it out for public usage. So thank you very much for listening to us, and we'd be happy to take any questions.
In that kind of situation, how do you ensure the sanitization, and do you have some kind of some stronger user authentication tied to the device so that if it changes hand and if someone else refurbish and use it, your key material is sanitized completely and then...
So there are two aspects, ma'am. One is how do you retrieve the certificate and the key material or trigger the signing operation, which will anyway be a combination of some PIN plus a facial or a biometric authentication. And two, if the device does change hands, which could be also a theft or a loss, there is anyway provision for certificate revocation, which will obviously revoke the certificate so that it cannot be misused from that point onward. And a fresh certificate can anyway be issued because the KYC that we do is valid for a certain period of time. So a request for a fresh certificate can anyway be triggered from a new device as well.
So you are not looking at entirely sanitizing the storage in the secure enclave with the intention of...
That can also be done, but that will be subject to the user's sort of maturity. If it's an enterprise, they typically have mobile device management solutions, which can be used to completely wipe out the storage layer as well.
Good session, thank you.
Thank you, sir. You can please. I would like to invite Shri Anup Kumar Pandey to felicitate our honorable speakers. Srinivasan. I would also like to call Mr. Sai Prasad KP, sir, to please come on the stage.